Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about factoring special cases.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, 16n squared minus 9, and we need to factor this completely. One thing I noticed at first, my b value is 0, it's not written. My a value is a perfect square, and my c value is a perfect square. So this is our special case here. We look at, 16, right? Square root of 16 is 4. So we can see this is going to be some case of 4n times 4n. 4n times 4n gives me the 4n, or 16n squared. Since there's no b value, if we do this, there's a plus and minus right here. Now we look at the 9. What's the square root of 9? Well, that's going to be 3. So we put a 3 right here and a 3 right there. So now let's look at this. 4n times 4n is 16n squared. 4n times a minus 3 plus 3 times 4n equals 0. They cancel each other out. There's a 0bx right there. 3 times a minus 3 is a negative 9, and there we have our answer. 4n plus 3 times 4n minus 3. We're given this problem right here. 4m squared minus 25, and we need to factor this completely. Well, first thing I notice, no b value. B value is 0. My value, my a here, is a perfect square, and so is my c. So I know it's going to have some form like this. We take the square root of 4, which is 2. We have 2 and 2 here. M squared, m, and m. So 2m times 2m will give us that 4m squared. Now what's the square root of 25? Well, the square root of 25 is 5. Put a 5 here and put a 5 here. If we do a plus and then a minus right here, we actually have our answer. Notice 2m again times 2m is 4m squared. 5 times a negative 5 gives you that negative 25. Here's the kicker. 2m times a negative 5 plus 5 times the 2m gets you 0, and that's that 0bx right there. So our final answer is 2m plus 5 times 2m minus 5. We're given this problem right here, 16b squared minus 40b plus 25, and we want to factor this completely. What I notice here is that my a value and c value are both perfect squares. So we know it has to be factored in some form like this. Well, square root of 16 is 4, so put 4 here and 4 here. B squared, well, square root of b squared is b, and b. So now we can see when I multiply this out, 4b times 4b will give me that 16b squared. 25. Well, square root of 25 is 5, so we have a 5 here and a 5 here. All right, so 5 times 5 gives me that 25. But be careful, we have a minus 40 right there. Well, the 25, if they're both positive, right, we have a negative number. If I make this actually a negative and a negative, negative 5 times negative 5 gives me the positive 25. Now watch this. 4b times negative 5 is a negative 20b. Do that again. Negative 5 times 4b is a negative 20b. Add those together, we got that negative 40b, and now we factored this. Well, we actually can write it in simpler form. Same thing written out here. Let's go simplify it down. 4b minus 5, and we can write that all squared. Same thing written twice. So our final answer is just 4b minus 5 all squared. We're given this problem right here, 4x squared minus 4x plus 1, and we need to factor this completely. We'll look at the first value, our a value. It's a perfect square. Square root of 4 is 2, and we can see it's going to be in some form like this, or it could be. Our c value is also a perfect square. 1. Square root of 1 is 1. Put a 1 here and a 1 here. Oh, don't forget the x's. 2x times 2x gives me that 4x squared. But notice here we have a negative 4. Well, if I have a minus 1 and a minus 1, that also, when they're multiplied, gives me a positive 1, so we're still good. Now let's check the minus 4x. Well, 2x times a negative 1 is a negative 2x. Negative 1 times 2x is also a negative 2x. Add those together, and you get a negative 4x. But we're not done. We have this in factor form, but it can be simpler. Notice it's the same thing. So we can write this as 2x minus 1 instead of multiplying by itself, we can square it. And so now we have our final answer, 2x minus 1 in parentheses all squared. We're given this problem right here, 9x squared minus 1, and we need to factor this completely. Well, what do we notice? Our 9, our a value, is a perfect square. So is our 1 a perfect square as well. So watch this. We can write this. We know it has to be in some form like that. Square root of 9 is 3. Square root of x squared is x. Put that here. 3x times 3x gives me 9x squared. Got it. Now let's look at the 1. Well, square root of 1 is 1. So 1 times 1, when these get multiplied, give us 1. So now we have to look about the inside. Well, our b value is 0, right? So that means if I have this as a positive and this is a negative, 3x times a negative 1 is a negative 3x. We add that to 1 times 3x, well, it's 0x. So that cancels out, we have no b value, and there we have our answer. 3x plus 1 times 3x minus 1. We're given this problem right here, n squared minus 25, and we want to factor this completely. Notice in front of, well, n squared is our a value, which is 1. Don't really write that. We know when we factor, it needs to be in some form like this. Well, n squared is a perfect square. N times n is n squared. 25, our c value, is also a perfect square. Square root of 25 is 5. So n times n will give us n squared. 5 times 5 is, well, positive 25. We need a negative 25. So if we have one positive, one negative, they multiply out, they get a negative 25. But here's the trick. Our b value is 0, not written right here. N times a negative 5 is a negative 5n. 5 times n is a negative or positive 5n. They cancel each other out when we add them. 5n plus a negative 5n is 0. Don't need to write that. So here we have our final answer. N plus 5 times n minus 5. We're given this problem right here, n to the 4th power minus 100, and we want to factor this completely. Notice here the a value in front of n is 1. Keep that in mind, but square root of 1 is 1, so that doesn't really affect anything here. The square root of 100 is 10. 100 is also a perfect square. So the square root of n to the 4th power, well, that's n squared. So if I put n squared and n squared here, when they're multiplied, they get us n to the 4th power. What about 100? Well, square root of 100, like I said, was 10. 10 here and 10 here. 10 times 10, 100. Almost there. We do not have a b value right now. That b value is 0, so it's not written. So what's going to happen here? How do we make sure that when we multiply this out, we don't get a b value? And that's going to be a plus and minus. That helps us with 10 times negative 10, which is a negative 100. Got it. But watch this. N squared times a negative 10 gives me negative 10 n squared. 10 times n squared is a positive 10 n squared. Add them together, you get 0. No b value. So we have our final answer here. N squared plus 10 times n squared minus 10. We're given this problem right here. A to the 4th minus 9, and we want to factor this completely. The coefficient in front of a to the 4th is just 1. Okay, that's our a value. A little tricky. Okay. Well, we know it has to be in this form. Square root of a to the 4th is a squared. So if I have a squared here and a squared here, a squared times a squared gives me a to the 4th. Now the 9. Well, square root of 9 is 3. It's a perfect square. So 3 here, 3 here. 3 times 3 gives me a positive 9, but I need a negative 9. So if I make this a plus, that a minus, 3 times a negative 3 is a negative 9. We're good. But how do we know about our b value being 0? There's nothing written here. A squared times a negative 3 is a negative 3a squared. 3 times a squared is a positive 3a squared. That will cancel each other out, making 0, and so makes our b value 0. So now we have our final answer here. A squared plus 3 times a squared minus 3. We're given this problem right here, k to the 4th minus 36, and we need to factor this completely. Our a value in front of the k to the 4th, well, kind of a value, but our coefficient in front of there is 1, making k to the 4th also a perfect square. So we factor out like this, k to the 4th, square root of that is k squared, k squared. Alright, k squared times k squared, k to the 4th. Got it. Let's look at the 36. Square root of 36 is 6. 6 here, 6 here. Well, 6 times 6 is 36, but this is a negative. So if we make one positive, one negative, we have that part taken care of. 6 times minus 6 is a negative 36. But here's the kicker. Our b value. Our b value here is 0. Well, k squared times a minus 6 is negative 6k squared. 6 times k squared is a positive 6k squared. Add them together, you get 0. So we have our answer. K squared plus 6 times k squared minus 6. We're given this problem right here. N to the fourth minus 49, and we want to factor this completely. Well, let's look at n to the fourth here. That's a perfect square. So is 49. And that gives me my clue. Square root of n to the fourth is n squared. So if I write it in these two places, n squared times n squared is n to the fourth. 49. Well, square root of 49 is 7. So 7 times 7 gives me that 49. But it's a negative 49. So we have to make that a plus and minus. So positive 7 times negative 7, negative 49. But we don't really have it inside b value, because we know that's going to be multiplied out. But watch this. Excuse me, n squared times a negative 7 is a negative 7n squared. 7 times n squared is a positive 7n squared. We add them together, we get 0. And so we actually have our answer here. N squared plus 7 times n squared minus 7. We're given this problem right here. 98n squared minus 200, and we want to factor this completely. Well, first thing I'm noticing is, well, these are kind of large numbers, and 2 goes into both of these evenly. So I'm going to pull a 2 out. 98 divided by 2 is 49, and we have n squared here, and 200 divided by 2 is 100. So now we have 2 times 49n squared minus 100. But now something else is revealed. 49n squared and 100 are both perfect squares. Meaning, when we have it in this form, 49n squared, the square root of that was just 7n. And we put that here. 7n times 7n gives us that 49n squared. But what about the 10? Or 100? Got ahead of myself. Square root of 100 is 10. So 10 times 10 gives me 100. But we need a negative 100. So if this is positive and that's negative, positive times a negative 10 is a negative 100. But what about the b value, the inside? It's supposed to be 0. Well, this is where this becomes kind of nice. 7n times a negative 10 is a negative 70n. 10 times 7n is a positive 70n. Add them together, it becomes 0. So now we have our final answer here. 2 times 7n plus 10 times 7n minus 10. We're given this problem right here. 3 plus 6b plus 3b squared, and we need to factor this completely. Before I dive right in, I'm noticing that 3 goes into all 3 parts. So I can pull a 3 out here and make it a little easier to look at. Pull a 3 out of 3, we get a 1. This becomes a 2b from the 6, and the 3b squared becomes just b squared. A little easier to factor now. Okay. Well, notice the b squared and the 1 are both perfect squares. So what does that do for us here? Well, square root of 1 is 1, so that 1 times 1 gets us that 1. B squared is, well, square root of that's b, so we have b times a b here. So b times b is b squared. If we make these both positive, b times 1 and b times 1, add them together is 2b. So we have that actually written out here, but we're not done. Don't get ahead of yourself. We can write this as 1 parenthesis of 1 plus b all squared, because they're the same thing, right? So now we have a final answer here, 3 times 1 plus b all squared. We're given this problem right here, 400 minus 36v squared, and we need to factor this completely. Well, first thing I notice here is that I can simplify this a little bit. I can pull out a 4 from both parts. Pulling out a 4 from 400 gives me 100. Pulling out a 4 from 36 gives me 9. So we have a 9 here, v squared. And now we have 4 times 100 minus 9v squared. Okay. But notice the 100 and the 9v squared are both perfect squares. So that helps us out here. We're having some form here of 2 parentheses. Square root of 100 is 10. So 10 times 10 here is 100. Square root of 9v squared is just, well, 3v. 3v times 3v gives me 9v squared. But we need a negative 9v squared. So if one's positive, one minus, that gives us a negative 9v squared. But how do we know if this is correct? We have a b value in a sense in here that's 0. 10 times a minus 3v is a negative 30v. 3v times 10 is a positive 30v. Add them together, we get 0. So now we actually have our answer. 4 times 10 plus 3v times 10 minus 3v. We're given this problem right here. 100x squared plus 180x plus 81, and we want to factor this completely. Well, notice my a value is 100. Square root of 100 is 10, so it's a perfect square, especially with the x squared. So if we have 10x here and 10x here, 10x times 10x gives me 100x squared. What about the 81? Well, square root of 81 is 9. So we have a 9 here and a 9 here. 9 times 9 is 81. Well, how about that b value? If we have positive 9 and positive 9, 10x will then be multiplied by 9, giving me 90x. 9 times 10x is 90x. Add them together, we have 180x. But we're not done. This still can be simplified a little more. Notice both these parentheses are exactly the same. So when they're multiplied, I can write it as such as 10x plus 9 all squared. And so that is our final answer now. 10x plus 9 all squared. We're given this problem right here. 10n squared plus 100n plus 250, and we want to factor this completely. One thing I notice is that 10 is in all three parts, so let's simplify this a little. If we pull out a 10, we're left with an n squared plus, well, 10n here, plus 25. Okay, now from here, our first term and last term are both perfect squares. That's a thing that I think about in C, and that's going to help us here. Square root of n squared is n, so n times n here is that n squared. Square root of 25 is 5, so on the ends here, 5 times 5 is 25. But what about the inside? Well, make this positive, make it positive. We see that n times 5 is 5n, 5 times n is 5n. Add them together, we get the 10n. So we're pretty much good here, but we still can simplify a little more. Bring down this 10, and notice that this n plus 5 is multiplied by itself. So we can write this as squared. So now we have our final answer, 10 times n plus 5 all squared. We're given this problem right here, 49n squared minus 56n plus 16, and we want to factor this completely. Notice my first and last term are both perfect squares. What do I mean by that? Well, square root of 49 is 7. Square root of n squared is n. 7n times 7n is 49n squared. What about 16? Well, square root of 16 is 4. So 4 times 4 is 16. We have a minus in here, so I'm going to put a minus here and a plus here. Let's go put a plus there. I like having pluses first. Nope. They're both minuses. Excuse me, I got ahead of myself here. So if it's a minus and minus, we're still okay with a positive 16. Minus 4 times minus 4 is a positive 16. What about this negative 56n here? Well, 7n times a minus 4 is a minus 28n. Negative 4 times 7n is a minus 28n. Add them together, we get a negative 56n. That's on the inside. So we almost have our answer, but notice these two are exactly the same now. We have 7n minus 4 and 7n minus 4. They're being multiplied. So we can write it as 7n minus 4 all squared, and that is our final answer. We're given this problem right here, 49x squared minus 100, and we want to factor this completely. Notice my 49x squared and 100 are both perfect squares. So when I write this out here, square root of 49 is 7, and square root of x squared is x. So if you have 7x and 7x here, that gets multiplied to be 49x squared. Same with 100. Square root of 100 is 10. 10 here, and 10. But it's a negative 100. So 1 has to be positive, 1 be negative. 10 times a negative 10, negative 100. We're almost there. Well, they have no b value here. B is 0. But notice, The way we have it set up here, 7x times a negative 10 is a negative 70x. 10 times 7x is a positive 70x. Add them together, we get 0. And so this is our final answer, 7x plus 10 times 7x minus 10. We're given this problem right here, 1 minus r squared, and we want to factor this completely. This is so simple it becomes a little tricky. We know it has to be in some parenthesis form like this. But notice that 1 and r squared are both perfect squares. Square root of 1 is 1. So 1 times 1 here gives us that 1. R squared, well, square root of r squared is r. We have an r and an r. But it's a minus r squared, so 1's going to be positive, 1 negative. Positive r times negative r is a negative r squared. Perfect. What about our b value? There's nothing in the middle. Well, watch this. R1 will be multiplied by negative r, and r will be multiplied by 1. When we add those two together, they cancel out, making it 0. So here we have our answer. 1 plus r times 1 minus r. We're given this problem right here. 10p to the third power minus 1960p. And we need to factor this completely. I notice there's a p in both parts and a 10 in both parts. So let's pull that out. We have a 10p here, and we're left with p squared minus 196. Okay? What do we know from here? Well, p squared I know is a perfect square. So 10p, and I'm going to write it like this. I have p times p is that p squared. But what about 196? Well, square root of 196 is equal to 14. So if I put a 14 here and a 14 here, 14 times 14 gets me that 196. And it's a negative 196. So one's positive, one's negative. And that gets us here a negative 196. But watch this. P times a negative 14 plus 14 times p gives me 0, which is what I need there, a 0b value. So now we actually have our final answer here. 10p times p plus 14 times p minus 14. We're given this problem right here, 343b squared minus 7b to the fourth power, and we want to factor this completely. Well, there's a reference for 343 that I know, and if you know it, put it in the comment section down below, but we'll see. Alright, we see 343 and 7, and I can pull out a common factor, right? I can pull out a 7 there from both of them, so I'm going to do that to help make this a little easier. If I pull out a 7 from both parts here, 343 divided by 7 is 49. But we also can pull out a b squared as well in both parts. So if I pull out b squared, I'm left with just 49 here. If I pull out a 7b squared from the first part, I'm left with a b squared. So now a problem that looked pretty difficult isn't so bad. So let's look at the inside here. Well, 49 and b squared are both perfect squares. So I'm bringing down the 7b squared, but I'm now going to write it in some form like this. Square root of 49 is 7. 7 in both parts here. 7 times 7 is 49. Square root of b squared is b. B and b. b times b is b squared, but we want to minus b squared. Make one positive, one negative. And that actually, by having the same thing here, but one positive, one negative, will eliminate this b value here. 7 times negative b is a negative 7b. b times 7 is a positive 7b. Add them together, you get 0. So now we actually have our final answer full of 7's and b's. 7b squared times 7 plus b times 7 minus b. We're given this problem right here. 81b to the fourth power minus 900v squared, and we want to factor this completely. First thing I notice is that I can simplify this a little bit right off the bat without factoring. I can pull out, well, a common factor, so it is factoring in a way. 81 and 900 both have 9 in it. V to the fourth power and v squared both have v squared in it. So if I pull that out, I'm left with a 9v squared minus 100. Okay? So now from here, it's a little more manageable. 9v squared and 100 are both what we call perfect squares. So we bring down this thing, but what does that mean? That means it's a little special case here. 9v squared, square root of that is 3v. 3v times 3v is 9v squared. Square root of 100 is 10. Put a 10 here and 10 here. 10 times 10 is 100. Well, it has to be a negative 100. Make that positive, make that a minus, and 10 times a negative 10 is negative 100. But what happens when we multiply 3v times negative 10 and 10 plus 3v? When we do that, add it together, they actually cancel each other out, and that's the beauty of how this is set up here. So our b value, which is 0, will occur. So we actually have our final answer here. 9v squared times 3v plus 10 times 3v minus 10. We're given this problem right here. 200m to the 4th power plus 80m to the 3rd power plus 8m squared. And we have to factor this completely. But I want to see if I can pull out a common factor right from the beginning. 8m squared actually goes into all parts. So if I pull out an 8m squared, what am I left with? Well, 200m to the 4th power divided by 8m squared is 25m squared. 80m to the 3rd power divided by 8m squared is a 10m. And lastly, 8m squared divided by 8m squared is just 1. So now we have, well, a much simpler problem. 8m squared times 25m squared plus 10m plus 1. So let's look at this first part, 25m squared and then this 1. Both are perfect squares, meaning if I take the square root of each one, I'll get a number that's easy there, right? An integer. Square root of 25 is 5. Square root of m squared is m. Square root of 1, it's right here, sorry, 5m here. Square root of 1 is 1. So at 5m times 5m, 25m squared. 1 times 1 is 1. Well, it's a positive 1, and we have a positive 10m in here, so I'm going to put a plus sign here and a plus sign there. Now watch this. 5m times 1 gives me 10m. 1 times 5m gives me 10m as well. Oh, sorry. Misspoke. 5m times 1 is 5m. 1 times 5m is 5m. Add them together, we get 10m. Made a mistake there. Got it? I'm glad I caught it. Okay, hopefully you caught it too. If you did, let me know down below. So we're done? No. What do we have to do? Notice I have 5m plus 1 times 5m plus 1. The same thing written twice. So I bring down the 8m squared, but I can write this as 5m plus 1 all squared then. So now we have our final answer. 8m squared times 5m plus 1 squared. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math. Minute Math, Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.